Hi guys, now we are looking at ninth standard mathematics, chapter 1. Okay, this is where we stopped in the last class, constructing the square root spiral. Okay, take a large sheet of paper and construct a square root spiral in the following manner. Start with point O. From here, draw a line segment OP of unit length. Okay, draw a line perpendicular to OP, that is PQ. Okay, at a unit length. Now join OQ. OQ is your root to now. Now draw a line segment QR perpendicularly from OQ, okay, with a unit length. Now join this R from O. This will gives you root 3. Now draw RS with a unit length perpendicular to OR. Now join O and S. Okay, that will be your root 4, and you can keep on doing till root 2, root 3, root 4, root 5, root 6, and so on. Okay. So, how to represent the real numbers on the number line through successive magnification? In the previous section, we have seen that any real number has a decimal expansion. Now, first let us see how to represent terminating decimal on the number line. Suppose we want to locate 2.776 on the number line. We know that this is a terminating decimal and this lies between 2 and 3. Now, magnify between 2 and 3 and take 10 divisions from 2 and 3, 2.1, 2.2, 2.5, and so on up to 2.9. So this lies between 2.7 and 2.8. So magnify 2.7 and 2.8. Okay, then this is what it will appear. This is how it will appear. Okay, now this lies between 2.77 and 2.78. Now magnify 2.77 and 2.78. Okay, what is the value? 2.776. So now you can easily indicate 2.776. Okay, that is here. Okay, so let us see the successive magnification. Okay, uh, by looking at an example. Now we have to look at 3.58 power. Okay, up to 4 decimal places. 4 decimal places means it becomes 5.3.5889. Okay, right. Now what you need to do is you need to magnify between 3.5 and 3.6, and after that 3.58 to 3.59, that you need to magnify. Okay, so what you will get? 3.588 and 589. And you have to magnify between 3.588 to 3.589. The eighth division is 3.5888. Ninth division is 3.5889. Okay, up to 4 decimal places means he took only 5.3.5888. Now you can do this one and this one also, right, using the same method. Now operations on the real number. We have learned in previous class the rational numbers satisfy the commutative, associative and distributive laws under addition and multiplication. And also we learned that rational numbers are closed with respect to addition, subtraction and multiplication. Can you say irrational numbers are also closed under 4 fundamental operations? Let's now look at the following example. Plus root 3 minus root 3 is 0. 0 is a rational number. So minus root 5 minus root 5 is 0. So this is addition. Plus root 3 plus minus root 3. Root 2 into root 2 equal to 2 is a rational number. Root 7 by root 7 equal to 1. Here is a rational number. What do you observe? The sum, difference, quotient and product of irrational number need not be irrational. They can be rational as well. So we can say irrational numbers are not closed with respect to addition, subtraction, multiplication and division. Okay. Suppose you want to add a 3 root 2 to 2 root 2. The sum can be written as 5 root 2, and if you subtract 2 root 2 from 3 root 2, you will get root 2. Shit said 5 root 3 plus 2 root 7 equal to 7 root 10. Do you agree with him? No, that is not possible. You cannot add them just like that. Okay, they are under root. Okay, you cannot add 5 plus 2. You cannot add 3 plus 7 also. He is completely wrong. Okay, How can you find the value of 5 root 2 minus root 8? Root 8, you write it as 2 root 2. So 5 root 2 minus 2 root 2 will be 3 root 2. Okay. Let us see some problems on irrational numbers. Okay. Check whether 5 root 2, 5 by root 2, 21 by root 3 plus 5 by 3 are irrational numbers. 5 root 2 is irrational. No doubt in it. Okay. 5 by root 2 is also irrational. 21 plus root 3 is also irrational. 5 plus 3 are also irrational. If q is rational, let us see irrational. Then q plus s, q minus s, q into s, q by s are irrational numbers. Okay. Sum of a rational number and irrational number is irrational. Subtraction of rational and irrational number will give you irrational. Multiplication of rational and irrational also will give you irrational number, and division of irrational number and irrational number also gives you an irrational number. Subtract 5 root 3 plus 7 root 5 minus from 3 root 5 minus 7 root 3, that you can easily do. Okay. Multiply 6 root 3 into 13 root 3 అంటే what you will get 3 into 13 into 6 into 3. Okay, that is what you will get. We know list some properties related to square roots which are useful in various ways. Let a and b are non-negative or real numbers, then root ab is equal to root a into root b. Root a by b is root a by root b. If b not equal to 0, root a plus root b into root a minus root b equal to a minus b. A plus root b into a minus root b is a square minus b. Root a plus root b into root c plus root d equal to root ac plus root ad or root bc plus root bd. Root a plus root b whole square, a plus b plus 2 root ab. Okay. Root over a plus b plus 2 root ab is nothing but root a plus root b. This one only. Okay. Just apply square on both sides, you will get this one. Let us look at some particular cases of these properties. Simplification, they asked, you just multiply 3 into 2, 6, 3 root 2 plus 2 root 3 plus root 6. Okay. Now this is 2 plus root 3, 2 minus root 3, a square minus b square. 4 minus 3, 1. Okay. Root 5 plus root 2 whole square, a square plus 2ab plus b square. Okay. 5 plus 2 root 10 plus 2. That means 7 plus 2 root 10. Root 5 minus root 2 into root 5 plus root 2. 5 minus 2, 3. A square minus b square. Find the square root of 5 plus 2 root 6. Here 6 can be written as 3 into 2. This can be written as 3 plus 2. So this is nothing but root 3 plus root 2. It is in the form of root 3 whole square plus root 2 whole square plus 2 into root 3, right? Or rationalizing the denominator. Can we locate 1 by root 2 on number line? What is the value of 1 by root 2? How do we find the value? As root 2 is 1.4142135, which is neither terminating nor repeating, can you divide 1 with this? No, it does not seem to be easy to find 1 by root 2. Then we can do one thing. You can multiply. You can multiply with root 2 in the numerator and denominator, so that you can rationalize the denominator. Okay. So it becomes root 2 by 2. Yes, it is half of root 2. Root 2 you already know, right? You know how to represent root 2. If you just compute half of it, you will get 1 by root 2. Okay. Can we plot root 2 by 2 on the number line? It lies between 0 and root 2. Root 2. Okay. So, what is rationalization factor? If you multiply root 2 with root 2, it becomes rationalized. Right. It becomes a rational number. And similarly, root 2 into root 8 also becomes rational number. Root 16 is nothing but 4. Similarly, if you multiply root 2 with root 18 also, you will get 6. So that means these are all the rationalization factors for root 2. But the least, that means the minimum of these will be root 2, right? So it's better to consider, it is convenient to use simplest of all. Simplest one is root 2 here in this example of a given rational number. For doing rationalization, it's better to take simplest one. Find rationalization factor of the denominators 1 by 2 root 3. This is you have to multiply with root 3. This one root 5. This one root 8. Okay. Rationalize the denominator of this. So you have to multiply with 4 minus root 5. 4 minus root 5 by 16 minus 5. 11. Find the value of x plus 1 by x. How to find? First find the value of 1 by x. Rationalize 7 minus 4 root 3 by 7 minus 4 root 3. So 7 minus 4 root 3 by 49 minus 48 is 1. Okay, now we add x plus 1 plus x, it is nothing but 14. Okay, now how to simplify this? Rationalize it first. Okay, 7 minus 4 root 3. This one is 2 minus root 5. 7 uh, minus 2, 5. Minus 4 root 3 plus root 5. Like that. Okay. Law of exponents for real numbers. Let us recall the laws of exponents. A power m into a power n is a power m plus n, a power m whole power n equal to a power m n, a power m b power n equal to a power m minus 1 if m is greater than n, and 1 if m equal to n, 1 by a power n minus m if m is less than 1. A power m b power m equal to ab whole power m. A 1 by a power n is a power minus n. A power 0 is 1 when a not equal to 0. Here a, b, m and are integers and a not equal to 0, b not equal to 0. A, b are called as base, the base, and mn are called exponents. Okay. Right, suppose we want to do the following computation 2 power 2 by 3 and 2 power 1 by 3. How much? 2 power 3 by 3 means 2 only. 3 by 3 is 1, right? This is 5 power 4 by 7. This is 1 by 3 minus 1 by 5. 15. 5 power minus 2 by 15. This one is 77 power 1 by 17. Okay. Okay. So 5 square is 25. So root 25 is 5. Our second root of 25 is 5. 2 cube is 8. So cube root of 8 is 2. Okay. Similarly 2 power 4 is 16. So fourth root of 16 is 2. 2 power 5 is 32. Fifth root of 32 is 2. 2 power 6 is 64. Sixth root of 64 is 2. Similarly, if a power n equal to b, nth root of b is a. Okay. Nth root b is b power 1 by n. A power n whole power 1 by n is nothing but a. Let a greater than b a real number and n is a positive integer. If b power n equal to a for some positive real value b, then b is called the root of a. And to write nth root a equal to b. In the earlier discussion, laws of exponents were defined for integers. Let us extend the laws of exponents to the basis of positive real numbers and rational exponents. Let a greater than 0 be a real number and p and q are rational numbers. Then we have a power p into a power q is a power p plus q, a power p whole power q, a power p q, a power p by a power q, a power p minus q, a power p into b power p, ab whole power p. Nth root a is a power 1 by n. Now we need to simplify this. This is 2, this is 5 power 4 by 7, this is 3 power minus 2 by 15, or 1 by 3 power 2 by 15. Last one 77 whole power 1 by 17. Simplify. This is 4, this is 2, 343 means 7 cube, right? So 7 power 3 by 5. Okay. Third, what is third? If n is a positive integer greater than 1 and a is a positive rational number but not nth power of any rational number, then nth root a or a power 1 by n is called Third of nth order. In general, we say positive. The positive nth root of a is called a third order radical. Here a is called radicand, nth root is called radical sign, and n is called the degree of the radical. So there are two forms of third. Exponential form is a power 1 by n. Radical form is nth root a. Here are some examples for third: root 2, root 3, cube root 9. But cube root 9 cannot be third. It can be. Square root 9 cannot be third. Consider the real number root 7. It may also be written as 7 power half. Since 7 is not a square of any rational number, root 7 is a third. Consider the real number cube root 8. Since 8 is a cube of rational number 2, root cube 8 is not a third. Consider the real number root 2 and root 2, that is 2 power of whole power 1 by half, nothing but 2 power 1 4. It is also a third. Write the following thirds in exponential form: 2 power 1 by 2, 9 power 1 by 3, 20 power 1 by 5, 19 power 1 by 17. Write the thirds in radical form: 5 power 1 by 7, 17 power 1 by 6, 5 power 2 by 5, 142 power 1 by 5. Okay. This is 7 power 5. This is sixth root, 7th root 5, 6th root 17, 5th root 25, second root 142. Simplify the following expressions. Yeah, you just need to no need to rationalize. 10 plus 35, 45 plus 5 root 5 plus 2 root 7. That's it. A plus b into a minus b, a square minus b square, 25 minus 5, 20. This is 20. This is 3 plus 7, 10. 10 plus 2 root 21. This is 11 minus 7, 4. Classify the following numbers as rational or irrational. 5 minus root 3, irrational. Root 3 plus root 2, irrational. Root 2 minus 2 whole square, that is also irrational. 2 root 7 by 7 root 7, rational. 2 by irrational. 1 by root 3, irrational. 2 plus root 22 minus root 2, that is rational. Because 4 minus 2 is nothing but 2. In the following equations, find the whether the variables x, y, z represent rational or irrational numbers. X is root 7 irrational, y is rational, z is 0.01. 0.01 can be expressed as a fraction, so rational. U square is 17 by 4, that is irrational. W square is 27, that is also irrational. T to the power 4 is 256. 256 means 4 4 6 6 36, 36 6 no, 2 power 7 is 128, 2 power 8, 2 power 8, 2 power 8 over power 1 by 4. Okay, 4. So can be expressed as 4 power 4. So this is irrational. Every third is an irrational, but every irrational need not be third. Just for your answer. Rationalize the denominator of the following: 1 by 3 plus root 2. Rationalize, if you do rationalization, 3 minus root 2 by 3 minus 2, 1. This is root 7 plus root 6 by, you have to multiply with root 7 plus root 6 on both numerator and denominator. Here you will get root 7 plus root 6. Here 7 minus 6 is 1. So this is root 7 by 7. This one is root 3 plus root 2. So root 18 my plus root 12. Now you need to rationalize it. 6 minus 4 root 2. 6 minus 4 root 2 whole square by 36 minus 16 into 2. 32. That is 4. Okay. 6 minus 4 root 2 whole square, you can do 36 plus 24, that is 40. 36 plus 24, 40 plus 20, 60 minus 48 root 2, Okay, all divided by 4. This one root 7 root 5 whole square divided by 7 plus 5 is 12. This one 3 root 2 minus plus 2 root 3 divided by 6 minus 6. Oh, like that. 9 2 is 18. Okay, 18 minus 4 3 is 12. 18 minus 12 is 6. So denominator is 6, numerator 3 root 2 plus 2 root 3. This one also you can rationalize. Find the value of root 10 minus root 5 by 2 root 2 up to 3 decimal places. Quite simple. Here you will get 1 by 2 by root 5 minus root 5 by root 2. So rationalize with root 2, root 10 by 2. Okay. Root 10 can be written as root 2 into root 5. Root 2 value you know, root 5 value also you know. So this is 2 power 6. So this is 2. This is 2 power 5. So this is 5. This is 5 power 4. So this is 5. This is 4 square. Okay. 4 cube. 64. And what about this 3 power 5? 5 will cancel out. 3 square. 9 is the answer. And what about this 6 power 6 is this? So 1 by 6 is the answer. How I got to know that? 46656 216 into 216. See 46656 we did square root 216 into 216. So nothing but 216 equal to 3 into 72. 72 is 8 into 9. So 216 can be written as 2 cube into 3 cube. Okay, right. Then this will be 2 power 6 into 3 power 6. Okay, so 2 3 will remain. 2 into 3 is 6 6 6. So 1 by 6. 3 power 4. This is 7 cube. 3 power 4 is 3 minus 8 into 7. 8 into 7 plus 15 into 2 plus 15. 15 5 15 is 225, right? Right. This is 56. This is 30. 30 plus 15 45. 45 plus 3 48. 48 56. So minus 8 is the answer. Okay, 56 is greater than 48, right? A and B are rational numbers. Find the value of A and B in each of the following equation. Multiply with root 3 plus root 2. Okay, so root 3 plus root 2 whole square. 3 plus 2 is 5. So A is 5. Okay, A equal to 5. What about B? B equal to 2. 2 root 6, right? So 2. Similarly, you do it for this one. Find the square root of root 11 plus 2 root 30. 5 6. So root 5 plus root 6 is the answer for this. Okay. So what we have discussed so far in this chapter, we have discussed the following point number in which we can be written and the way where p and q and are equal to called rational number. A number which cannot be written in the form p for integer p q are called irrational number. Okay. The decimal expansion of a rational number is either terminating or non-terminating recurring. The decimal expansion of irrational number is non-terminating and non-recurring. Oh, the collection of all rational irrational numbers is called real numbers. There is a unique real number corresponding to every point on the number line. Also corresponding to each real number, there is unique point on the number line. If q is rational and s is irrational, q plus s, q minus s, q into s, q by s are irrational numbers. If n is a natural number other than a perfect square, then root 2 is an irrational number. The following identity is sold for positive real numbers a and b. Root ab equal to root a into root b. Root a by b equal to root a by root b. B not equal to 0. Root a plus root b into root a minus root b equal to a minus b. A plus root b into a minus b root b equal to a square minus b. Root a plus root b whole square is a plus b plus 2 root ab. Root over a plus b plus 2 root ab is nothing but root a plus root b, just opposite. To rationalize the denominator of root a plus b, we have to multiply with root a minus b on both numerator and denominator, where a and b are integers. Let a greater than 0, b greater than 0 the real numbers, p and q are rational numbers. Then a power p into a power q is a power p plus q. A power p whole power q equal to a power p q. A power p by a power q is a power p minus q. A power p into b power q equal to ab whole power. A power p into b power p is ab whole power p. If n is a positive integer greater than 1 and a is a positive rational number but not nth power of any irrational numbers, then nth root a or a power 1 by n is called third of the nth order. That's it, guys. We'll meet with the second chapter in the next class. Okay, thank you. See how beautiful this nature is. You also start planting the trees. Let us bring a new change in our society. Let us plant the trees and let others plant the trees. Let's take this pledge seriously from now. Thank you.